This video is going to give us a quick overview of things to focus on and review for both parts 1 and 2 of the Chapter 4 test. You'll notice on the objectives slide, or our learning goals slide, I've broken down 4.1, 4.2, 4.10, and 4.6 into the part 1 test that we will take on Thursday. So everything in purple is going to be in the Thursday test. Everything in orange will be in Friday's test. So taking a look at kind of how to prepare as you go through your review and you look at all of your homework, that's kind of our game plan. The rest of this video is going to highlight some things in each of the lessons for you to be mindful of as you study for the test. The very first lesson defined quadratic functions for us. We talked about the parent function centered at 0, 0, with the axis of symmetry x equals 0 and the y-intercept of 0. From there, we changed the vertex. It opened up or down, and we basically performed a transformation. Now, down below, we talked about describing transformations. You're not going to be expected to describe in words. I know we initially talked about doing that, but I think we're not going to. However, it's mindful to recognize if you have, whoops, I meant to put a color there. If you have a negative out in front, that your arrows should open down. Remember how narrow that was when we were done sketching it? So arrows are at the bottom. If you have a positive number, but it's a fraction, the shape of the graph is going to be wider than the original parent function. Now remember, you can always make a table if you want to find more values, but also be mindful of your time. So if there's time and you want to make sure your graph is sketched appropriately, you can always make a table and plot additional points. When we talk about graphing a function in standard form, remember standard form is where you have ax squared plus bx plus c as your template for your formula. To find the vertex, we do negative b over 2a for x, and we plug it back in to get y. Remember, the key thing here is that the vertex is an ordered pair. So make sure you have an x and a y. Your axis of symmetry has to be x equals a number. So make sure it's an equation. I know you have that written down. Underline that or maybe highlight that. If you have just 7 as your AOS, that does not count. It has to be an x equals form. And then draw that with that dashed line on your graph. So make sure to sketch it as well as list out the equation. And then remember the y-intercept is just that constant, because if you plugged in everything else, or if you plugged in 0 for x, everything else would cancel out. And then we reflect the y-intercept over the axis of symmetry. You'll be required to list out these parts. Vertex equals this. Axis of symmetry, write the equation. Y-intercept this. Be detailed in your work right here, like we were in the notes. Take your time on this. So that's why you need to be prepared so that you can be mindful of the time you have in class. Okay, so it's kind of a little trade-off there. That was the big takeaway for standard form in lesson 4.1. Vertex form is when you have one parenthesis being squared. You possibly have a number out in front, our a value, and then it's x minus h squared plus k. The vertex is an ordered pair, and remember it's h comma k. So the h value is kind of what was throwing students off when we took our quiz the first time. Remember, it's negative h by definition, so if it's x minus h in your equation, then h would be positive. But if it's x plus something in the parenthesis, then h would be negative. Take a look at that example on the right. It's x plus 2, so technically that means it was x minus negative 2. So h is that negative 2. That's why our vertex was negative 2, comma 5. So just be careful for that. And then we have our axis of symmetry, x equals again, it's the same number as the vertex, so we drew that in on our graph, like so. The work for this one was step 3, so make sure you know that that's the work in this form. Plug in x equals 0. If you can remember these steps, it's going to be much more time efficient than trying to multiply everything out and convert back to standard form. I know some of you did that on the quiz and you ended up getting stuck. So try to memorize these steps and it'll save you more time in the long run. Our last form was intercept form. And that's when you have the two parentheses. Almost looks like you factored your quadratic function. And there may or may not be that a out in front. Remember, to get your x-intercepts, the first thing you want to do is just set the parentheses equal to 0 in whatever form they're in. It's minus and minus in the formula, but whatever the parenthesis is, that's exactly what you do to solve for the p and q values. Those are the numbers you plot on the x-axis, what you solve for in step 1. Then for the vertex in step 2, notice you take those two answers and you plug them into p plus q. You always add them together, whatever they equal in step 1, and then divide by 2. And that's the x-coordinate of the vertex. Plug it back in to get the y-coordinate. So to see what I mean, let's take a look at that example up here at the top. Notice we had x plus 3 and x minus 1. To get our x-intercepts, we did x plus 3 equals 0, and we had to subtract 3 to move it over. And then x minus 1 kind of looks like more like the definition. We add 1 to move that over. Those are your p and q values. So this is p right here, and this is q. So then for the vertex in step 2, we took the p and the q. We didn't change any signs. We just took those p and q values and we plugged them into that formula down below and added them together to divide by 2. Make sure you're looking at these steps carefully as you're trying to find the difference in the types of graphs that you're looking at. The last part of 4.2 was combined with 4.10. We just did converting from these types of forms back to standard form. This is not going to be on your test. I know it's on the review, so make sure to practice it, but I'm not going to put that on the achievement assessment. The part down below, I definitely am going to add. So let's take a look at lesson 410. When you're asked to write a quadratic function in either vertex or intercept form, follow these steps very carefully. If you know the vertex, you literally just plug the h and k into vertex form. If you know the x-intercepts, whoa, I don't know what I'm doing there. Hang on. If you know the x-intercepts, then you plug it in for p and q in intercept form. Make sure that you're using the vertex and the x-intercepts appropriately. Those are the numbers you plug in first. That extra point is what you substitute in for y on the right and x wherever you see it on the inside and simplify. Make sure you know which answer is the final answer for each of these, and your answer has to be an equation on your test. So you need to have y equals in your final answer or it won't count for full credit. There's practice problems like this on the review. Make sure you're focusing on those and asking questions if you need to. On your achievement assessment, I won't give you a picture and ask you to write the equation. I'll just give you that information like on the first two examples. So you won't be expected to know problems like C or D. When converting from standard form to intercept form, we factor. Remember, it's always important to look for a common factor first, and that's just something that all your terms would have in common in a polynomial type function, whether there's 2 terms or 3 terms. Sometimes there's nothing in common. Sometimes you can take out a common factor first. Make sure you know that when a equals 1, we just split c into factors that add to get b. Factors that add to get b. Take a look at the examples on the right and make sure you can do those again. Sometimes the factors are different, sometimes they're positive and or negative, sometimes they're the exact same. We had special factor rules here, the difference of 2 squares. So remember, if that bx term is missing but you're not asked to solve, you're just asked to factor, you can think of it as having that 0 in the middle. Come up with 2 numbers that add to get negative 49, or multiply, to get negative 49, but add to get 0. That would be positive 7 and negative 7. And you can write those in either order. Now when you're asked to find the zeros, that means you're solving. Solving means find the x-intercept. Remember, we set the equation equal to 0 first, factor, and then apply that 0 product property. Take a look at the steps for A and the steps for B to see if you can follow them. Because then in day 2, this is essentially 4.4. Same kind of idea, we're asked to just factor first, But now the number out in front isn't 1, and our process is different. Take a look at how we set those up and how we split that bx term in the middle. Remember, in this process, we went from 3 terms to 4 terms when we split that bx term. Solving, we still do all the parts that we did for a, b, and c, but then we apply the zero product property to get x completely by itself. Notice example B for this one. Remember, if it's equal to something other than 0, we've got to move everything over first, set it equal to 0 before we start to factor. Lots and lots of things to remember. On the achievement assessment for problems involving lesson 4.5, you're not going to be asked so much to simplify square root expressions like the first part, but it's all going to be kind of embedded in the simplify process for that second part. Remember, when you're asked to solve by extracting square roots, that means there's no there's no bx term to have to work with. So we isolate our x squared, take the square root of each side, remember plus or minus in your answer, and simplify that square root. So that's where the part up above will come into play when solving. You'll be asked to solve specifically by extracting square roots for at least one problem on the achievement assessment. Remember, sometimes when we were asked to solve, we got answers that didn't work out as square roots that were possible. That indicates we have an imaginary solution. This lesson is going to be in the first part of our Chapter 4 test, and we're going to focus more on the problems that were related to complex numbers than just the simplify piece. So we're going to focus on numbers in this form, a plus bi. I'll ask you to add and subtract, as well as flipping over to the back for that second part. You should know how to multiply and simplify a fraction using the complex conjugate. So back here, remember, anytime you FOIL or distribute, if you get an I squared equals -1. And look at each of those problems, how that affects the way you write out your final answer. All of them need to be in standard form of a complex number for full credit. Oops, I keep doing that, sorry. I'm trying to go through this too quickly. Down below, when we divide, remember, we don't technically divide, we multiply by the conjugate of the denominator. So this was 1 plus I, and we put it in parentheses. This one was 4 plus 5i, and we had to put all of that in parentheses. And this turns out to be a lot of multiplying. And remember to split your answer for these types of problems in your final result. So it's not just like 2 plus 3i all over 4. Make sure to split the first part and the second part. Remember, we're not going to do anything with complete the square at all. Go ahead and skip right to 4.8. Lesson 4.8, the quadratic formula. Remember, this has to be memorized on your test. It won't be given to you as you are going through how to solve. It will say specifically on the test to solve by either factoring, extracting square roots, or by quadratic formula. And remember, looking at our answers down below, you can have all real solutions, but you can also have imaginary solutions with I. And this is also where you'll be expected to simplify square roots, so we're still giving a little bit of 4.5 in our work here. Be sure to feel confident in all of these problems. If you have any questions on how we simplified, definitely ask. I would encourage you to especially try to simplify the insides, because that's where we seem to get stuck the most when we try to simplify together at the boards. While the discriminant is helpful in determining the types of solutions we have, I just feel like this is not something we absolutely have to be assessed on our test. I'm not going to ask you any specific discriminant questions. Discriminant on the test. You'll be asked to use quadratic formula to solve, so you'll get this part in those problems anyway. So no need to have to focus on these types of questions on your review. And of course, saving the best for last, interpreting word problems. Remember, we said that this is called the projectile motion problem because when you throw something up, gravity, so that g variable that typically we would define, pulls everything back down to earth. We said it looks like standard form. I keep doing that. It looks like standard form. H equals A times T squared plus B times T plus C. Now there's a lot of work that we can do with application, but typically our A value is going to be negative for the problems that we're doing in this chapter. Knowing that things will go up and come back down. Down below we talked about specifically what to look for and how to determine what you're going to solve. So keep in mind to review the when versus the what as far as how you're setting up and solving equations. You'll likely have to use quadratic formula or determine the vertex. So as long as you can read the word problem and look for those key words, when will it reach maximum height? What is the maximum height? When would it possibly land on the ground or maybe be at a different height? Those will be the key focus points on how to interpret an application problem. So this is a quick review of key features and key items to focus on as you study for your test on Thursday and Friday.